Assalamualaikum to Dr. Hasila. We are from Group 11 are going to present our Chapter 2 which is from Assignment Probability Theory in Finance. Based on our reading from article titled Optimization Model of Financial Market Portfolio Using Artificial Fish Swarm Model and Uniform Distribution, authored by Yao Kiao. It describes the problem how to make portfolio selection in the financial market. Our table of contents in this slide is about introduction, methodology, result analysis and discussion, conclusion, and lastly, references. The article introduced an innovative model that integrates uniform distribution with the artificial fish swarm algorithm that called by AFSA to improve portfolio optimization in financial markets. The model aims to enhance the global search capability and avoid getting stuck in local optima when optimizing the risk-return trade-off in portfolio selection.
For financial market portfolio, which the effective portfolio management in theory focus on risk minimization, which aim to reduce risk while achieving a desired return level, and return maximization under risk constraints, which is seek the highest return possible without surpassing predefined risk limits. And this condition reflects the core objective of portfolio management in balancing risk and return to achieve optimal performance according to the investor's preference and goals. For portfolio optimization, there is a lot of uncertainty in security market, which the markets are unpredictable due to the fluctuating prices and unforeseen events. So with using mean variance model, it can define the expected returns as the portfolio average return and expected risk as its variance. And with using statistical analysis, the random variable are used to analyze the random and uncertain nature of investment, return, and risk. Each individual xi in the swarm has the mutation probability PB. To determine if mutation occurs for a specific sub-element xij within xi, we need to generate a random number, and if the random number is less than PB, we need to proceed with mutation. To mutate xij by assigning a new random value, xij is equal to random number, and update the xi by applying a normal distribution transformation to x next. In the basic fish swarm algorithm, there is too much random generation of new solution that can lead to a loss of previously optimized solution. So it's important to balance between exploring new possibility and refining existing good solution to avoid regression. So for the first equation, it is preying behavior, which is yi current fish fitness is greater than y fitness threshold. The fish move toward the best visual position of xv. For the second equation is swarming behavior, which is if
Here
the
goes the
YOB,
reference for the
which is
research
swarm
article.
fitness, is greater than
Thank you.
y, the fish move towards the center of the swarm. For the third equation, it is the following behavior. If neither preying nor swarming condition are met, the fish remains in its current position. And for the fourth equation, it is the normalization, which is after updating the position, normalize the position using the formula. And for the last equation, which is roulette selection, To ensure the diversity, a roulette wheel selection mechanism is often used to update the swarm using the formula shown, which is the fish minus fish swarm eyes next equal to roulette fish minus swarm. Based on the optimization algorithm, we need to initialize a population of artificial fish, which the each representing a potential solution to the optimization problem, and randomly distribute the fish in the search space or initialize them around promising regions based on prior knowledge. And the Pareto domination is used. This is because it is the way to compare the solution when you have more than one thing to optimize for, like both cost and quality. And we're using the clustering behavior, which is referred to the tendency of data points and entities to group together based on similarity in the database. And now, the new fish group position is formed. After this, we will using the shoal merging because it is the process by which the smaller groups of fish come together to form the larger group. And now the new fish group is formed. Next, a pruning strategy is used because it is the process of reducing the size that will form the primitive fish and the new shoal of trim fish. And the congestion distance calculation is applied because it is used to assess the degree of the traffic congestion based on the various factors such as the specific region and network. And after this, the last step is applying again the pruning strategy in form
Construction of portfolio optimization on AFSA. Here we have figure 2, which is the process of the improved artificial fish-free search algorithm. Point number 1. The food concentration and crowding distance are used to evaluate behavior. Artificial fish can realize their own behavior through this evaluation. They will continue to move towards areas with high food concentration but not overcrowded. Then they will choose the best or better behavior and finally realize the fish swarm converges. Next point is when a typical transaction cost function is introduced, the model's constraint function becomes nonlinear and the effective solution set become non-convex and non-concave, indicating that the search space is irregular. Okay, so this necessitates using a highly robust algorithm that avoids them from falling into the level of mean absolute error, root mean square error, and correct trend rate are introduced to evaluate the prediction accuracy, and the running time of the algorithm is used to evaluate the convergence speed. Calculation formula is as follows. Okay, so the algorithm is extremely robust, but since the algorithm is random, the value of each parameter has some influence on the algorithm's convergence process and optimization result.
Data of our problem are the trading data of 25 stocks from the stock market for 450 trading days. MATLAB software are used for the experiment. The experimental parameters for testing the performance of the algorithm are listed at the upper right corner. Results show lower MAE and RMSE compared to other algorithms. With the highest CTR algorithm tested 100 times to assess cardinality constraint and confidence value impact on optimal value. Influence of cardinality constraint and confidence shown in figure 3 and figure 4. In figure 3, conditional risk values decreases with less constraint increase, aligning that diversified investment principles can reduce non-market risk. And in figured form, with constant expected return, higher confidence leads to the increased conditional risk, indicating higher risk aversion, showing that the investor aversion to risk a comparison result of Pareto quantitative distribution of different algorithms. In Figure 5, the improved AFSA achieved the lower risk at the same expected rate of return, approaching optimal linear programming solution with multiple Pareto optimal solutions. The improved AFSA and the traditional AFSA was tested by the test function, and the test was repeated 5 times in an independent environment, and the result shown in Table 2. Table 2 shows improved AFSA has better optimization and robustness than traditional AFSA, with significantly improved success rate in optimizing the test. The precision experiment of the model is carried out to verify the effectiveness and reliability of the improved method, and the result shown in Figure 6. Precision experiment result in Figure 6 show the improved models significantly higher accuracy compared to other models. The model achieved 93.56% accuracy at 0.4% higher than an SGA2 and 3.76% higher than the multi-objective optimization model, validating the improved method's effectiveness and reliability. To test the performance, Figure 6 and SGA2 model and multi-objective optimization model are used, and the result shown in Figure 7. Result in Figure 7 compare the model with an SGA2 and multi-objective optimization models. The optimized portfolio model in this paper yield higher total returns, offering the better investment skill to maximize income, minimize risks, and guide investor effectively. This demonstrates the effectiveness of the portfolio model for practical investment applications. The improved AFSA offers reliable convergence performance and overcomes issues like genetic algorithm sensitivity. It eliminates local extremes and obtains the global optimal state, effectively solving low convergence accuracy in
Last but not
algorithm
least, for the
optimization.
conclusion part, in the proposed optimization model, AFSA employs uniform distribution in both initializing and iteration stages to guarantee well-diversified candidate solution for generated algorithms that become diversified portfolios at inception until the completion of optimization process. Mathematical formulation which objective function that must be optimized by AFSA contains one part related to the evenness of distributions of assets. Here goes the reference that our group referred to. That's all from us. Thank you.